Welcome to another episode of Clean Critically. These are excellent ideas for manufacturers, brought to you by Darren Williams, Ed Koenigsberg, and me, Barbara, from the Product Quality Cleaning Workshop. Today, we will discuss soil and residue. Are they the same?
Let me introduce some of the team members here. This is the cleaning lady, Barbara Koenigsberg, and the rocket scientist, Ed Koenigsberg, both of BFK Solutions. They're experts in critical cleaning and contamination control, and they edited the 2-volume set of the Critical Cleaning Handbook. It's a great resource. I highly recommend it.
And we have on the other side, Darren Williams, professor of physical chemistry at Sam Houston State University, and the leader of the cleaning research group at SHSU.
So he's teaching cleaning to students. This is for everybody out here, for us practice manufacturers.
Excellent. Yeah, we're trying to develop the workforce for the future in the cleaning area.
So is it soil? And here's a number of soils of concern to manufacturers.
I think this is a partial list.
Oh,
So
definitely
it's
a partial
everything from FOD, so insects and birds and bird debris, to bacteria, to mystery contaminants.
Or is it dirt?
Or
And
is it residue?
We're going to ask today, is it residue? And is there a difference?
Yeah, if you put a drop of water-soluble cleaning or machining oil on a coupon and then dip that coupon in amazing new cleaning chemistry, of course, it's going to come right off. You know, just having something on your part, we might call that soil. It's matter out of place. But test that same cleaning chemistry on a production part and nothing may happen. So what's going on? Do you have the soil or do you have a residue? And are those the same thing?
Residue is often more adherent than the original soil. It may dissolve, a soil may dissolve in water once you cook it and do things with it. It's machine with it, it's something else. Adherent residue, adherent soil can impact product performance. So residue from on microsurgical blades, which emanated from straps used in rolling the steel.
Leather straps used to hone the blades.
And it sort of got ground in there and it became a residue. It was only detected during surgery. We certainly don't want to see field failure of navigation systems or failure of implanted medical devices. There can be residual. At one point, there were residual oils that left a residue, and they stuck. Okay.
So this was a demonstration that we actually did in Darren's lab down in Huntsville, Texas, at the university. Our goal was to create soils likely to be encountered in manufacturing. So to do that, we sort of cooked a cutting oil to emulate the effects of the heat that's generated during metalworking. And then we analyzed it by FTIR, Fourier Transform Infrared, which is a good fingerprint for organics.
Very good for a physicist.
Yeah, that's right. The goal was really to turn that soil into a residue, like what we're talking about, something that was sort of cooked onto the part.
So what happened, Darren?
Well, we saw dramatic changes. So what you see on the top, these are 2 spectra that were taken with the FTIR. The top one was a spectrum of the cutting fluid. And you can see there some CH stretches and some carbon-carbon stretches. That's what those 2 main peak areas are that you see. And then after cooking, drying, and creating an adherent residue, we see a lot of chemical changes. So you see a broad range of peaks. I guess the numbers may be difficult to see, but it's down to the right on that spectrum, just a whole blob of peaks. Those are new bonds that have formed in this material. And so we've definitely changed the chemical identity of this soil. It is now something new that is stuck to the part, and it was very hard to remove.
And so the blue, can we go back 1 second?
Sure.
Yes, because the top in red is a very simple water soluble cutting fluid. The second one down, all of those mountain ranges are compounds, and there are so many of them that it's real difficult to distinguish, and it's basically showing you how messy it looks.
Yes, we definitely changed the identity of it. And some of the ones were so stuck on the aluminum parts, we had to sand them off.
Oh, yeah, that
Yes.
was fun.
I mean, what we saw was a sort of a gooey caramelized mess, to put it
Yeah, that's the technical term.
technically.
So and as we
And as I pointed out, the FTIR scans showed much more structure, more peaks, different peaks. The point is, well, we asked, is the heated oil harder to remove than the original soil? And one of the questions we use as an analogy, which is easier to clean, sugar or caramel? Because caramel is what happens when you heat sugar and it turns into thousands of compounds. We wrote about that a few years ago in our BFK Solutions newsletter, Clean Source. It's still there on the web if you want to get it. The point is that
it's a good article.
Heat can help things like curing epoxies. Heat assists in cleaning, but it's also one factor that can turn a soil into an adherent residue.
Moving forward, why do we understand a little more about why the cleaning agent might not work? The label might say it works. The cleaning agent may remove the soil, but not the residue. The residue is very often much more difficult to remove than the original. And that means when you evaluate different cleaning agents, which we have reason to do from time to time, you want to get as close to reality as possible. If you're going to machine with something, you don't need it right out of the bottle. You want it after it's been machined. And always remember to test this on scrap parts so you don't have phooey moments. Don't test it on really things. Heated residue, even applied to a coupon, is easier to remove than actual soiled parts because the shape influences the cleaning. So you have to think about the test.
Right. Well, not only does the shape do it, but the actual process of heating on the part creates bonds that wouldn't be there that make it more difficult to remove.
Yeah, that's a good point. Well, thank you so much for tuning in on this short video on soil and residue. This is a course that teaches a little bit about that, but a lot about aqueous cleaning. It's our on-demand course. It's non-commercial. You can learn at your convenience and your own pace. There's 4 one-hour modules and 4 small quizzes after those modules that can sort of test to see if you've internalized the information. It also includes a half-hour discussion with one of us, the PQCW instructors, to address your particular manufacturing issue. It's been claimed by one of the attendees it's more fun than a bubble bath. So I think it's reasonably priced. You can find out more information at that website, shsu.edu/PQCW.
And we thank you.
Thank you for attending this episode of Clean Critically, and stay tuned for more adventures in cleaning.